We're now going to look at frame and suspension fundamentals and how these components are put together, and again, different applications that we see. So for instance, if we're taking a look at a highway truck, our frame is going to be used to support all the other components. Our drive axle, our fuel tank, our engine, our cab, sleeper. So all of these components have to be attached to the frame. So this is all taken into account when they manufacture and design a frame. So number one is, again, I can't just take any truck and use it for any application I want, because if it wasn't designed for that, the frame may not be strong enough for that. So for instance, if I have a single axle, I've got a day box on the back, where's my center of load? So if my center of load is, let's just say 5 feet in front of the rear axle, is that frame strong enough? Well, there's different things that they do. Is underneath the box they may run a full bar to help spread that load out over a longer distance. But when we take a look at some other applications, for instance, a gravel truck. Now in a gravel truck, most of the times what we see is we see the hydraulic ram in this position. Now what happens then is that's where the center of the pivot point is between the center of this axle and the center of this axle. So this is the maximum bending moment is right there. So is that frame going to be strong enough to support that, that amount of weight when we're lifting it? Again, when we take a look at a box like this, because we distribute the weight over a different distance, it changes where our center of our bending moment's going to be. When we take a look at a highway truck that's hauling a trailer. Now again, if we have a trailer on the back of this, all that weight's going to be on the fifth wheel. So the maximum bending moment of this is going to change depending on the weight here and the weight here. So there's on a trailer they use what's called a bridge formula. Because our trailer is longer, as we start to move the rear axles of the trailer forward, if we got sliding bogies, we can change what the bridge formula is depending on the overhang on the back of that trailer. So let's just take a look at the trailer. So if our center point is here on our truck, and we got our tires here, and we've got our tires here. Now as I move this further forward, the amount of weight on the back of that is going to increase, which is going to decrease the amount of weight on my fifth wheel, which is going to change the amount of weight where my pivot point is, where the maximum amount of force is that's going to bend that frame. That's called the bridge formula. So if I just take a highway truck, can I convert it into a gravel truck? Well, you can, but there's some things you have to do. Because of this maximum bending moment. Now, what does maximum bending moment mean? Well, it means the point at which a material will bend and return back to the point it was before the weight was put onto it. We also have, for instance, a twisting. Now we want our frame rails to be rigid, but we don't want them so rigid that they don't have any flexibility. So in a case like this, if I'm converting one to the other, I may have to put an insert inside the frame or an outsert on the outside of the frame to compensate for that bending moment so my frame just doesn't buckle. So if we take a look at a C-channel frame, and again, we have our cross members on the back between our drive axles. We'll have what's called a chair. Now, a chair is bigger than a cross member, and again, it helps support the twisting and movement, the torque from those wheels, so we don't end up with cracks in the frame. And then we have our very front cross member, which supports the front of our engine. Again, that's another cross member that's usually a lot stiffer and made of bigger material than these other cross members. Now, we don't see this type of cross or frame setup in highway trucks or off-highway. This is more of a vehicle setup. But what we see is we can see C-channel, which is probably the most common, or we can see box channel. We can also see I-beam on off-highway equipment. So when they engineer and they design a vehicle, every material has a certain amount of pressure which it can take. So for instance, aluminum will have 60,000 psi of pressure, where steel can take 110,000 psi of pressure. So they're going to design the frames for the application of the vehicle. Now, Mack came out with frames made of aluminum years and years ago. The problem with the aluminum is a thing called, I can't remember what it is called now. Anyways, the aluminum would start to peel off in sheets. And so what that did is it made the frame rails a lot weaker. So I was working in Vancouver and we had a gravel truck come in the night before, and they were dumping their load and it fell over and broke the frame rail. So the guy from ICBC come in, we went out and took a look at it, and it had just been freshly painted, and he said, "Do you have a chipping hammer?" And so we chipped away at it, and what it was is the aluminum had sheeted, had come apart, so they filled it with Bondo and then painted the frame and sold the truck. Claim was denied. So that was the last time I'd seen an aluminum frame. So everything is usually steel. But if we have dissimilar metals, what can happen is we can have an electron exchange in there, and again, the weakest one is the aluminum, and it will dissolve faster. So anytime we're working with steel and aluminum, galvanic corrosion, that's what it's called. To prevent that, we either have to put tar on it, or we have to put something that will prevent the electrolysis from happening. Okay, so if we take a look at terminology, so we have our upper flange, our lower flange, and our web. Now, we can have a larger web, which is going to give us a larger resisting bending moment. We can change the thickness of the C-channel, and that's going to make that frame rail stronger. So there's a thing called section modulus. You don't have to remember this. But what an engineer will do is it will give me the strength of that frame. So what types of stresses do we get on a frame rail? Well, we get all sorts of them. So here, this is the one I was talking about. So aluminum, 60,000 psi. When we get up to heat-treated steel frame rails, 110,000 psi. So almost double for the same type of material. Now, resisting bending moment is calculate the section modulus, calculate the yield strength, and then multiply the section modulus by the yield strength, and that will give you your resisting bending moment. Okay, so frame rails, they're heat treated, so we really have to be careful when we're welding on them. When we're drilling them, one of the things you'll notice on a heat treated frame rail is it's heat treated on the inside and the outside, but the center is still flexible, still soft. So when you're drilling, it'll be hard to drill, then you get into the soft material and then the hard material again. So again, do not heat or weld, do not drill, cut, or notch frame or flange. So what that means is, if we go back and take a look at, we do not want to do anything to this area in here. So no welding on that or drilling on that. If we're going to drill, it's going to be from this point to this point. Now the other thing is welding on the flange, anything in this area here. If it's before the front drive axles, no. But if it's after the drive axles, because that's not a load-bearing surface and it's not part of the structure, some of that you can. But be careful no matter when we're doing any welding or drilling. Okay, so when we're taking a look at a trailer, so how is the load supported on a trailer? Well, if we take a look at the center, we have our two I-beams with our cross members. And then we have our side rails. Now our side rails, they don't take a lot of weight. So they're not usually made out of real strong material, but what it does is holds all the side together. Where all our weight is in the center two I-beams. And then on top of that we have our decking, which helps hold everything together and keep it straight. So if you've ever noticed a brand new trailer, what you'll see is the trailer, it's got a big arc in it. And when they make the trailers, they take them out and then they'll arc them, so as soon as they put weight on them, they'll go flat. So I built a trailer for a guy in Kamloops, and when they took it to the frame shop to bend it, they put the straps over the side, and again, these aren't very strong, and they bent them. They had to bring it back. We had to cut them off and redo them. So they just, you bend it without the decking on it, so you can strap it down. Now the other thing we have is sliding bogies. So we can slide these rear drive axle, or these rear axles on a trailer back and forth. And what that's for is for changing where our weight distribution is on our trailer. So as we slide them ahead, it changes what our bridge formula is. Puts more weight on the back, puts less weight on the fifth wheel. Now, common frame rails, again, this is one that we see the most of, is C-channel. We'll see box channel and I-beam depending on the application. We already looked at this picture here, so we've already seen that. So again, when we're taking a look at frame rails for reinforcement, so if we take a normal web and we want to reinforce it, we can put an outsert on it. We can put an outsert plus an insert. We can put just an insert, or we can put a fish plate. Now every one of these has, again, different benefits. So it's really hard to put an outsert on a whole length of a trailer. So if I was to take a look at this, if I was to do all this, these would all be moved out. And it wouldn't work, because now it's moving out where my springs are. I can't do that. So I have to put an insert in here. So let's just say that this is my frame off my truck and I'm going to make a gravel truck out of it. What I have to do is I have to take all my cross members out. So depending on the style, if it's bolted, then you undo all the bolts, but if it's huck bolted, you got to take all the huck bolts out. Now if I'm going to put an insert in, I'm going to run the insert as far forward as I possibly can. Because remember where my resisting bending moment is going to be in a gravel truck. It's going to be where that hoist cylinder is. So I want to move that as far forward as I can. And with that, I'm going to have to shorten each of these cross members. Some of the cross members are slotted, so you can do that. Some are welded, so you can't. You have to cut the welds apart and shorten everything. So this is a place where I can only put an insert in. Because it changes other dimensions that I can't adjust. Now another thing that we want to look at is there's a thing called a body bound bolt, and we discussed this when we were discussing nuts and bolts. Now a body bound bolt is, let's say it's 5/8 of an inch. Dimension B will be exactly 5/8 of an inch. When we ream the frame out to accept a body bound bolt, when we ream it out to 5/8 of an inch, that bolt has to be tapped in. If I take a normal 5/8 bolt and go to put it in a 5/8 reamed hole, there'll be some slop in there. Now with that slop in there, we might get some movement and we get some shearing action taking place, and it might be enough that it could shear that bolt off, where a body bound bolt will not allow that shearing action to take place. On our frame, again, all of our suspension components are attached to that frame rail. So that frame rail, again, has to be strong enough to be able to withstand the flexibility of this machine going down the road or what type of terrain it's going over. The frame rail has to be strong enough to be able to withstand any forces. Again, the twisting forces on a frame rail, if it twists to the point where it's changing its resisting bending moment and it doesn't return back to normal, we can end up with some problems. And what we're going to do is our next video, we're going to go over on how to identify different frame issues and how to correct them. So there is a Hunter alignment thing that's set up where they use a laser to align the frame to make sure the frame's in alignment. But not everybody has access to this frame alignment machine, so I'm going to show you how we used to do it before lasers were an option. So if I want to check, there's a couple things. Let's just say that this vehicle got hit on this corner. Now what's going to happen is it's going to drive this frame rail back, and what we're going to find is the frame has what's called a diamond in it. Now in a normal frame, what I'm going to do is and this works great if you can move the machine, but if you can't move the machine because it's been in an accident, then you got to do it another way, and I'll show you how that's done. So if I can move the machine, I'm going to find points, and I don't need a lot of them, but I need a point on the vehicle. For instance, let's just say that this is the front spring pin grease nipple. So what I'm going to do is I'm going to take a plumb bob and I'm going to set points down. And I'm going to have the same on both sides. So if I pick the grease nipple here, on this side I got to pick the grease nipple here. Let's say these are Huck bolts here and here and here and here and at the back. Anything that's from the factory we can use as a contact point. So once I have all my points set on the floor, then I can move the vehicle out of the way. And what I'm going to do is I'm going to use a chalk line. And what I'm going to do is I'm going to go from point to point with the chalk line, and then I'm going to go down the center. Now by going down the center, it tells me if my frame has a side sway in it. What I'm going to do then is I'm going to measure this distance and then this distance. Now if the frame is nice and square, those two distances will be exactly the same. But if one distance is longer than the other, it means that one frame rail has shifted forward or backwards. So I want to go and I want to do all of these. So I'm going to measure them all. Okay? And once they're all measured, if all the measurements turn out the same, and again, we only have to usually do a couple, but if they all turn out, if we do one at the back and one at the front, and they turn out that this distance is equal to this one, and this one is equal to this one, chances are that the frame is square. But if we start to find that one is longer than the other, we end up with something like this. Because this distance here is going to be shorter than this distance here. So we know that we have a problem with the frame. And can we fix it? Of course we can. We can do anything. Okay. So one of the other things that we want to do is we want to check for a thing called side sway. So side sway is if we have if we're taking a look at the top, if our frame rail is like this. So we're going to put a string line. We don't have to do both sides because the cross members hold this together. Whatever we get on this side, we're going to get on this side. So what we're going to do is we're going to put a string line on, and let's just say that the distance from this frame here to where my string line is 24 inches. I'm going to make this back exactly the same at 24 inches. Then I'm going to go along with the tape measure, and I'm going to measure at different points from the string line to the frame. All of those should be 24 inches. If I end up, let's say right here, I end up with 26 inches, I know that my frame is bowed that way. If it's 23 inches, I know it's bowed the other way. And can that be straightened? Yep. And we can do that on a frame machine. And again, we don't have to do both sides, because whatever this side is, that side's going to be the exact opposite. We had one of the trucks come into our shop in Vancouver. It was T-boned and it had a 4-foot bow in it. The box was almost ripped off. It had a day box in the back, so we took that off, put it on the frame machine, and we took that 4-foot bow out. Or side sway, sorry. So checking to see if a frame is square. So let's just say that we don't have the ability to check the move the vehicle. So we got to do this all on the frame machine. So again, what I'm going to do is I'm going to pick 2 bolts that are from the factory. And I'm going to put my bar across it. And then I'm going to square it up. Now, if I could put my square there, and it's square to this bar and square to the frame and lined up properly, chances are that the frame does not have a diamond in it. And again, a diamond would be a frame rail that, this is exaggerated, but that would be a diamond, okay? Compared to having it, that would be square like this. When we're doing trailers, they're a little bit different, and I'll explain how those are done. Now that my bar is set there and I know that it's square, I'm going to take a tape measure and I'm going to go from my front axle to my bar on both sides. And again, both those distances should be the same. And what that will tell me is if my front axle is square to my frame. Then what I'm going to do is I'm going to go from this bar, and this is where I'm going to drop my plumb bob down on both sides, and I'm going to measure distance B. Distance B should be the same. And then what I'm going to do is I'm going to measure distance D, and distance D should be the same. And that will tell me that my front axle is aligned to my frame, my rear axle is aligned to my frame, or my front drive axle is aligned to the frame, and my rear drive axle is aligned to my front drive axle. Now, different types of suspension systems that we're going to see. There's a thing called sprung weight and unsprung weight. So from our spring pins up is sprung weight, from our spring pins down is unsprung weight. So why is that important? Well, as we're going around a corner, what happens is we're going to get some weight distribution and it's going to change. And again, our suspension system and our frame has to be able to handle that stresses that are placed on there without bending. So when we take a look at our rear suspension, we may have spring suspension with a walking beam. We may have rubber box suspension with a walking beam, or we may have air springs or an airbag suspension. So what happens when we go over a frame? So any type of spring setup that we're going to have is we're going to have a single anchor point. So this will have to be the front of the vehicle here. Now our spring is going to have to be able to change length as it moves up and down. And so on the back of the spring we're going to have 2 spring pins and a link. Now that link is going to join those 2 together. And usually what we have is something that looks like this, where we'll have our upper and lower spring pins go in this, and it will allow it to pivot and move back and forth. And that will be able to, again, account for the change in the spring. Now, the other thing is, as we go around a corner, we're going to have rebound blocks, and they're going to go up against the axle, and that just prevents the frame from going over too far and bending components. So these could have rubber blocks in them to just rebound blocks, just to allow it to stop. Now, we have longitudinal and transverse torque rods. Now, depending on the application and how the vehicle's set up, the longitudinal torque rods are going to go into the axle, and that's going to change the angle at which my housing is set up at. Now when we get into drive lines and how to change the angle of a driveline is by changing the length of this, and that's by adding shims. On our transverse torque rod, that is where we can move an axle over on a frame. So when we're talking about dimensions between tires and frames, by adding or subtracting shims on our transverse torque rods, we can shift an axle left or right. And why is that important? Well, if you take a look back here, this transverse torque rod goes to the right-hand frame rail, this one goes to the left-hand frame rail. So as we're going around a corner, what happens to our axle is it wants to shift. Now, one of the things we found with our logging trucks is we used to remove the front transverse torque rod because it tended to not want to allow the truck to turn on a ice road, and it would want to push it in a straight line. So by removing the front one, it allowed that front axle to do whatever it wanted to, and it prevented them from pushing them off the road. Now, we also use things called shock absorbers, and that's to stop what's called oscillation. Now, oscillation is something that can happen. If you've ever seen someone driving down the road hauling a trailer and the trailer starts to bounce, and every bounce gets worse and worse and worse, and that's called oscillation. And the only way to stop something like that is to speed up. Well, without a shock absorber on there to stop that oscillation, the spring is going to start bouncing to the point where it can lift it up off the road. Now, there's a thing called Jetstream. It was all about F-18s in Cold Lake and through their training. And two F-18s were coming into land one night, and one of the F-18s started to oscillate. And again, every oscillation as it starts will go, and every time it gets larger and larger and larger until it goes out of control. Well, the one F-18 just about ran in as it started to oscillate from side to side, almost took out another F-18 beside it. But the co-pilot, which was the instructor, took control and he stopped the oscillation. Now, there's another thing in flying is a thing called wheelbarrowing. So when you come in and you land on your nose wheel, it goes up and it goes down, it goes up, and every oscillation gets worse and worse. So in a case like that, I wheelbarrowed once in my life, and the first thing you have to do is you have to give yourself full power. As soon as you start to climb, give yourself full power, and then you can settle it in. So we want to break that oscillation, and that's what a shock absorber does. And again, how they work is internally they basically prevent the flow of oil, or they control the flow of oil to prevent the oscillation from happening. Now, when we take a look at how suspensions are mounted, now we looked at spring suspension, rubber block suspension, and airbag suspension, but a solidly mounted suspension, so this is bolted right to the frame rail, and we have our two walking beams. Very solid suspension, it doesn't tip that much, but it is rough as hell. Now, when we're taking a look at our equalizer beams, again, there's not a lot of give in these things. Now, when we take a look at a spring, a semi-elliptical spring, now there's two things that we want to take a look at. One's called a constant rate spring and one's a variable rate spring. So because this one has a rod here and our contact point is here and here. Now, this is called a variable rate spring because we can change the length of that spring. As this spring straightens out, the length changes, it shortens. So we can vary, that's why it's called a variable rate spring. If we take a look at how a constant rate spring works, this is a constant rate spring because this length never changes. It might pivot this as it moves up, but the overall length from this point to this point never ever changes. So they call this progressive, but it's also a variable rate. So here's our contact point here and here, And as this moves up, you'll see that that contact is there and there, which is shorter. So that's why they call it a variable rate spring. The other thing we might see is auxiliary springs or overload springs set up on a spring pack. Now, these never contact that until a certain amount of weight is put onto them. So normally if I'm going down the road and I'm empty, those overload springs don't make the road ride any rougher because they're not in contact. It's only when it's fully loaded or almost fully loaded that these will work. Steering axle suspension, again, if you take a look, because we have a 3 pins and a movable point, we have a single anchor point on this, and it's always at the front. So we have our single anchor point. The only reason we have this at the back, and there are some manufacturers that have theirs set up, I believe it's International, use a variable rate spring. So what it does, it doesn't have an eye, it just sits in a pocket. And so as the suspension moves, it makes that spring shorter. So it would be a progressive or a variable rate spring. This one here, the way this setup is, with a single anchor point and our adjustable back end there, that is a constant rate spring. Now off of this, if you remember back from the last 2 videos, we have a shim here. So what does that shim do? Well, that is our caster shim. That gives us positive caster. The other thing when we're taking a look at how these are set up is making sure that our spacer plate. Now our spacer plate, some vehicles have them, some don't, and that's just to make sure that our frame rail is totally level when we're empty. And again, our front is fixed, and this is on an International. So what we have here is we don't have a spring pin, but what we have is a rubber or a nylon rubber block. And what that does is allows the spring to slide back and forth as this moves up and down and changes the length. On a trailer, again, if we take a look at this, this is a variable or progressive rate spring, because this here controls where my axle is going to sit. All that spring does is moves up and down. If you undo the U-bolts, there's nothing to attach that spring in there. You can pull them out. What else? Now, when we're taking a look at rubber block with I-beams or walking beams, now some of these will have 2 rubber blocks, some will have one in the center. If there is a round one in the center, that is your overload spring. If it doesn't have it, then there's no overload. This is a Hendrick suspension. They are a tough suspension, but you can get one of these stuck in on a pavement if it's out of alignment a bit. So how this works is, this is our frame rail, this is our suspension, this goes down to our nut, and this is our rubber block. So as we start to load it down, basically what we're doing is compressing that rubber. Air ride suspension is probably what we see the most in on-highway vehicles because it gives the operator a very smooth ride. So we have our spring setup that goes over our axles down and to our air ride. We have our torque rod here that goes to our axle to keep our axle in alignment. Now, setting height on an airbag, how most of us do it is by, we know what the dimension is. Let's just say the dimension's 40 inches from the floor. We'll take a tape measure, we'll adjust the leveling valve. How you're supposed to do it, and I don't think I've ever done this, is you're supposed to set the rear frame rail at the height on a set of jack stands, set the leveling valve up, and then take it off. Never ever done that before. There are separate special tools on some suspensions on how you set them. So what you need to know is, where do you set your suspension height and what is that dimension? Also, we have dump valves. So for instance, if I want to back underneath the trailer, I'm going to dump the airbags. I'm going to back underneath, lift the airbags back into the fifth wheel, lock it in place, and then go. They're handy to have. All vehicles that have air springs should have them on there. So this is probably one of the most common, but you might see a double convoluted. And how many airbags a vehicle has? Well, they vary. A tandem drive might have 4 airbags, or they might have 8. The other thing that came out years ago was dual leveling valves, one for each side. A lot of the drivers, they took them off and went to a single leveling valve because it was trying to balance, get the two to be in perfect balance was always a chore. Okay, so what happens if you take a look at the leveling valve itself, as we're going down the highway and this drive axle is moving up and down, the leveling valve has a silicone fluid inside that will cause a slight delay in the leveling valve from making an adjustment. Otherwise, the trailer would be moving up and down the road like this. It would adjust every time you moved it. So there's always a 1 or 2 second delay in that leveling valve to allow for that spring to move up and down. Okay, we will also see air ride cabs now. So in an air ride cab, our front portion of our cab has got pivot pins so that the cab can move up and down. And again, we might have a single airbag or a double airbag on the back with a leveling valve. We also have shock absorbers again to prevent the cab from oscillating. And that's it.